Good morning, students. Welcome to online lecture series of discrete mathematics. In last lecture, we have studied the homogeneous solution. So, to find the homogeneous solution, so you have to remember two steps. First, you have to find out the characteristic equation, right? Then you have to find out the roots of that characteristic equation. Right? So, here in last lecture, let's see this one, right? So to find the homogeneous solution, first to find out the characteristic equation, then roots of the characteristic equation. So how to find out this characteristic equation we have already studied, right? So we'll see how to find out this roots of the characteristic equation. So there are different cases are there. So in first case, if roots are distinct, suppose alpha 1, alpha 2, alpha 3, alpha k are the roots of the characteristic equation. If these roots are distinct, then solution of homogeneous recurrence relation is AR equal to A1 alpha 1 raised to R plus A2 alpha 2 raised to R plus up to AK alpha k raised to R. This A1, A2, AK are the constants which are to be determined by the initial conditions. Means whatever this A1, A2 are there, using the initial conditions, we have to find out the values of this A1, A2 up to AK. We have to find out the values of this A1 and A2. So here, see the example. See an example. First example is find the solution of AR plus 2 minus AR plus 1 minus 6AR equal to 0. Here we have to find out the homogeneous solution. So first step, find out the characteristic equation. So here highest degree is 2 for the given equation, right? So alpha square minus alpha minus 6 equal to 0. This is the characteristic equation. So using this characteristic equation, we have to find out the roots of this characteristic equation. So here, how to find out the roots? So here, whatever this minus 6. So we have to find out the two numbers such that whose multiplication is minus 6 and addition is minus 1. What? Here for alpha square minus alpha. So for minus alpha, the coefficient is 1. So whatever two numbers you have to find out, whose addition is minus 1 for this coefficient and whose multiplication is minus 6, right? So for this alpha minus 3, that is minus 3 plus 2. These are the two numbers. So minus 3 plus 2 multiplication is minus 6 and addition is minus 1. Right? So here, alpha minus 3, alpha plus 2 is equal to 0. Therefore, alpha equal to 3 comma minus 2. So roots are 3 comma minus 2. So these roots are distinct. So the solution of the given recurrence relation is AR A1 alpha 1 raised to R plus A2 alpha 2 raised to R plus AK alpha k raised to R. So how many values of alpha here? 2. So alpha 1 and alpha 2. So A1 alpha 1 is 3. So 3 raised to R plus A2 minus 2 raised to R. So this is to find the solution of a given recurrence relation for this particular equation. So in next example, find the solution AR plus 2 plus 2AR plus 1 minus 3R equal to 0 with initial conditions are mentioned here, that is A0 equal to 1 and A1 equal to 2. So here first find out the characteristic equation. So characteristic equation is alpha square plus 2 alpha minus 3 equal to 0, right? So alpha square, so here multiplication is -3 and addition is 2. So alpha square plus 3 alpha minus 3 equal to 0. So here alpha is equal to 1 comma -3. So these are the two roots for the given equation, 1 comma -3. So these roots are the distinct. So solution of reconciliation is AR equal to A1 1 raised to R plus A2 minus 3 raised to R. Right? So here initial conditions are mentioned, A0 equal to 1 and A1 equal to 2. So here value of AR, so R value of R are 0 and 1. So here put to find A1 and A2, we have put R equal to 0 in equation number 1. So and put R equal to 0 in equation number 1 and put R equal to 1. Then A0 equal to A1 plus A2, and second after putting R equal to 1, A1 equal to A1 minus 3A2. So what is value of A0 and A1? A0 is 1, A1 is 2. So 1 is equal to A1 plus A2 and 2 is equal to A1 minus 3A2. So subtract these two equations. So we will get -1 is equal to 4A. So A2 is equal to -1 by 4. So put this A2 in a given equation, right? So 1 is equal to A1 plus A1 minus 1 by 4. So A1 is equal to 5 by 4. This one. So A1 is equal to 1 plus 1 by 4 is 5 by 4. The homogeneous solution is, so here you have to put the values of A1 and A2 in a given homogeneous reconciliation. So AR equal to 5 by 4 1 raised to R plus -1 by 4 minus 3 raised to R. So this is the homogeneous solution for the given equation.